So it's been a while since the last episode. Life took some more time than expected, but fortunately I found some time to create this recording today. So let's get started. In the last couple of episodes, we implemented crafting. Entities could work at objects to transform items into other items, and when they were done, those items would be put into their inventories. Um, what I would like to do is that when these items reach a certain amount, we will reuse the preferred pickup stack size for that. If they have more than that in the inventory, they should spawn a new job, a store job. And we implemented the store job itself in the last couple of episodes. Today, we are going to implement the behavior where a craft job that finishes spawns a store job if necessary. And to do that, we need a place to store these items that were created. And we will assume that we do that on an empty tile near the entity. So we need a new function that gives us an empty tile somewhere in the world where we can then store the item. So let's get started. So we start Xcode and we open our project, and we need a new test, a new world test, and these will be for finding empty tiles near somewhere. So let's look into create a marker, find empty tile near. We will start with a naive case that we have a find empty tile near, and we have a world, and the world will have a tile at a position where we can put some stuff on, say a floor, and then we want to assert a nil that if we do world find empty tile near this position, we get a result back. Now this won't compile because the findEmptyTileNear function was not implemented yet. So let's go into our let's disable these, and let's disable the UI tests and focus on the base builder test and the other test types, and implement a step for the findEmptyTile function. So let's go into our world. And let's see where we were doing something for items. This is item management, so this looks like a reasonable place to put it. And let's implement a function find empty tile near position. And we'll have a max radius where we will look. Be an integer, but that defaults to 10. And we might find a result, but if we don't, then we return nil, and that's what we'll do for now as well. So now we can run the test and see the test fail. And that's because we still need to implement our findEmptyTileNear function. So let's do something. So let's have a radius variable, and while our radius is smaller, less than or equal to our max radius, then we can do something, and we need to make sure, if we won't forget, that we increment max radius just to be sure that we don't somehow we don't somehow forget this and create an infinite loop for ourselves. So what we'll do is we'll loop through the tiles within a radius. And we create a point. X and Y. And if our tile is empty, then we return our point. Note we haven't implemented the tile is empty function yet, but we'll do so in a minute. If we found an empty tile, then we can return that position. Otherwise, if even after all these loops we haven't found anything yet, then we return nil. We assume there is no empty tile near enough to store something. So let's create a private function tile is empty. It takes position and returns a boolean. And for now, let's just return false. So our test should still not succeed because this one always returns false. So let's make sure that it can also return true if needed. So let's return true for now and see our test now pass. Our test passed. Let's do the other world test as well. Those run as well. So let's implement more complicated test case. So what if we want to find an empty tile near the location, but we are outside the range? So an available tile is outside of the range specified, and then we expect nil to be returned as well. So we will have our world, and at the end we will have an assert nil for our world. Right. Empty tile near position 0 with the max radius of instance 5, and let's create a world. Where every position is indeed a floor, and at every point we have an item stack. So there's a pre-existing item stack here. There's an item, that's some item, and it has an amount, say 1. And then we have one location that is available. So let's create a vector that says x minus 20 and y minus 20. And this is a floor. And this one is empty, but it's out of range. So this test should pass. Let's see. So we did get something back. And that's because we're not yet checking whether a tile is actually empty in our tile is empty method. So let's go back into our world. And first let's see that if items at position is nil, and is not nil, then we return false. And go back to our test and run a test. And we can also run the other tests as well. Okay, so we implemented a range and checking for non-empty tiles. So let's continue and create a test case. For this specific situation, what if you have an item stack that is defined somewhere in the world but has an amount of 0, for instance, because everyone is taken out of it? And I think we should assume that that is also an empty tile. However, our current implementation treats that exactly as an occupied tile. So that doesn't work. So what we should do is we should make sure that it also works with a 0 item stack. I'll call this an item stack with an amount of 0 item stack. Let's create a world. And make sure that the center tile is 4. And then we will create an item stack. The amount will be 0. And I assert that we get from our world findEmptyTileNear this position with a max radius of 0, that we do not get a nil value back. Now let's run the test. You will see it's failing. So let's go into our world and change this a bit to say that we have an existing item stack here. And if existing item stack dot amount is 0 or is bigger than 0, then we return false. Otherwise, we also consider it an empty tile. And let's run the test. Test passes. We can refactor this a bit, I think, to make it a bit more readable. Run our tests. And these passes. Also, I don't want to be able to store items in a wall. So let's test findEmptyTileNear returns a nil for a wall. So we need again a world. We need the position 0 set to a wall tile, and we need to exert nil that world findEmptyTileNear 0 with max radius of 0 is nil. And let's run the test. And let's implement this check. So here, let's check if tiles position void can be default equals a wall, and we return false. Let's run the test. And now the test passes. And I want to do something similar for void tiles. So I don't want to be storing anything into the void, because then it's kind of weird if you can pick it up. So we just need to make sure that the world tiles 0 is indeed a void, and then the test remains the same. So we need to add that check as well. Run the test. Okay, let's continue. Let's see where we are. And I also want to do a check on objects. So I don't want to store anything where there's already an object. So I should find an empty tile near returns a nil or a tile with an object. So let our world variable set tile position 0 and the tile to floor. We will set an object, and to make the test a bit more interesting, I'm not setting it up the exact location where I'm going to check. I'm setting it left of that, but I'm making an object that's wide, so it does cover the position we're going to test for. So we have some object, and it has a size 3 wide and 1 high. And then we can assert nil that we don't get a result. findEmptyTileNear 0 with a max radius of 0. So let's run this. Test fails. So we should add one last check to the tiles is empty function. And this is an object exists at position. We return false. Let's run all the tests. And they all pass. So we now have a function for finding empty tiles where to put stuff in. Now what we should do is make sure that we actually spawn storeJob after crafting. So we have the job test here, and let me just show the, where is it? The minimap. Okay, so I have my craft jobs here. And right before the store jobs, I'm going to write a test to check whether I actually get a store job after crafting. So let's create a function called test craft job spawns store job after crafting when more than preferred tag amount is in our inventory. So let's create an item to craft. And an example item. And let's give it a preferred pickup tag size of 10. And then let's create a craft job. This will be a job with a job goal to craft an item stack that takes an item, that's our item to craft, and an amount 5, and a target position, and a build time of 1. And then we need a world. Then we need to set the tile to position up to be a floor, otherwise we can't place anything there. And then we need an entity. Example entity in position 0. We push this new job on the job stack, and we put some in its inventory in advance. So we'll have an item to craft, but we will have 8. So that's less than the preferred pickup stack size, but after completing the craft job, we will have more than this value. So then we would expect the store job to be spawned. So let's check that. So let's update the entity in our world. And then let's look at what is our top job. And we will take our entity jobs.peak. We need to try this because this is a throwing function. That's also why I'm making this test flowing. Then we can check if the top job is indeed a store job. And that leaves us with an item to store stack. But we can get out of the top job.job call. If this fails, then we print out a message, expected the top job to be a store job, but found, what did we found? A top job, something else, and then we return. Finally, now we have done all this, we can assert that the item to store stack item is indeed the item to craft, and the amount is the preferred pickup stack size. Let's see. I think we're missing a parenthesis here. So let's try and run this again. This should be good. We have then a target position and a build time. Oh. This is build time. Our build is successful, but our test fails, and that's because we haven't implemented the spawning of the store job yet. So let's go into our entity and look at our job completion handlers and change our craft job a bit. So we have our inventory. If the inventory item stack item is bigger than the item stack item preferred pickup stack size, then let's try and find a store position. And this requires a reference to the world, so let's assume that the world was passed in to this function, so we can do world.findEmptyTileNear current position. And if this succeeds, so we have a store position available, then we can create a new job, create a store item job for the item stack.item. The amount will be the item stack.item preferred pickup stack size, and our position will be the store position. Then we can also log this entity created job of week description, and we can give a default value if this is for some reason nil. And this should be enough to satisfy this this test. So let's run the test. Oh, this is self.name. And we should pass in the world here. Let's run the test. Test succeeds. Let's run all of our tests. Okay, so that succeeds. But perhaps we can also make it visible in the game itself. To do that, let's go into our game content and take our cooked meals and give it a preferred pickup stack size of, let's see, 5. And let's make sure we have an asset. No, we don't. It's empty. Let's give it. Let's copy these cooked meals and rename them to cooked meal. So we at least have something to show them. And let's see what happens when we run this. So our entity is installing the workbench. It's picking up the food. It's converting the food into cooked meal. And once it has enough, it's putting the cooked meals on the empty tile, in this case of the floor here. And indeed, these are 5, which is exactly the pickup stack size. And the worker is indeed still holding 5 cooked meals. If there was a 6th one, then it would find a different place to store those. So I think that's enough for now. Next time we will work on installing objects from the UI, so we'll have a bit more gameplay by allowing you to choose where to install something. For now, thanks for watching and have a good day.